So welcome everyone. Welcome to Physics by RN. I am RN. I have done my masters in physics from IIT Delhi and now I am doing my PhD from IISc Bangalore. I am running this Physics by RN Institute from last 2 years and we have many future plans for this. And in the same context, I have started the lecture series for GATE 2023. So I am taking 8 lectures and lectures has been started from yesterday and it is a second session. Yesterday we covered canonical transformations and Poisson brackets. Today we will do another very crucial topic which is EM waves. Now electromagnetic waves is inherently a long topic, but there are few areas which I want to touch upon. If you know those areas of EM waves, more or less your EM waves is done. You can say it's done. So let's begin very quickly. So EM waves in means electromagnetic waves. We all know that. All are mature enough to understand what EM waves are. So these waves have electric field and a perpendicular magnetic field. Both are oscillating, as a result giving rise to an electromagnetic wave. Now the few very important properties of electromagnetic wave we all know is it can travel in space itself. There is no requirement of any sort of matter for EM waves to travel. So EM waves can travel in free space as well. So very first topic which you should know before starting EM waves, I would recommend you to read, that is Faraday's law. Faraday's law, that I think you should go ahead and read by yourself. It's a very easy thing to do. So whenever you want to read electromagnetism, doesn't matter what your background is or what you from where you have done your BSc or MSc, always follow DJ Griffith's book. Always follow. You should have a very good habit of reading this book and you should have a very good understanding of this book. There are at least 3 chapters which are extremely important in this book. Chapter number 2, 5 and 7. If you have a good grasp of these 3 chapters, then your electromagnetism will remain good for competitive exams. Okay. So read about Faraday's law, how he discussed that changing electric field can produce magnetic field and the vice versa can happen. So that you should know that what is the origin of electromagnetic waves. So electromagnetic waves itself started with the Maxwell equations. There are 4 Maxwell equations. We all know, we are studying this from class 11, 12th. So what are those 4 Maxwell equations? 2 equations are for electric field and 2 are for magnetic field. Very first equation, del dot E equals to rho by epsilon naught. So very first question I have for you is, what is the form of these 4 equations? Is this a differential equations or integral equations? Very simple thing to ask. The 4 equations which I have written.
Differential.
So is it differential or integral? Very quickly, if someone can answer.
Differential.
Yeah. So differential form is always easy to handle. So we like to write that in this form. There is also integral forms. I would recommend you all to write these 4 equations in integral forms as well, so that you have a better clarity what is going on here. So first equation, what is the name of the first equation, if anyone can tell me? Very simple. Del dot E equals to rho by epsilon naught. What's the name of this equation?
Gauss law in electrostatics.
Gauss's law, right? Gauss's law. So can anyone tell me what does Gauss's law explains very in one line? Very quickly. Let's see from where we have to begin. So what is Gauss's law in one line? Anyone?
So it is a measure of number of field lines passing through a surface area.
Okay, so it states that the flux of an electric field passing through any given area is dependent upon what is the charge
Sir,
enclosed inside, right? What is the
isn't
charge?
isn't
Yeah.
that thing is a place for integral form
No,
for
it
differential?
doesn't matter in which form you write, right? Gauss's law is Gauss's law.
That's correct, but when we take the flux explanation, it is generally described by integral form. Not,
Yeah, it is
I
written.
understand.
Yeah, okay. So what is your interpretation of differential form then?
So that is a question.
So the equation, the what you have said is right but incomplete. So del dot E you should look it as a divergence. So divergence is also representing the flux. So that does not mean that you all when you are talking about flux you only have to discuss about integral form. So del dot E means divergence. Divergence means how the
Yes,
electric field is diverging. So that
yes,
represents
yes, yes,
flux itself, right? So there is no problem in
yes.
that. So del dot B equals to 0. It explains that there should not be any monopole. Del cross E equals to minus curly B by curly T is something called Faraday law, which comes into play. And it explains that if you have a changing magnetic field, it means if your current is changing, then you inherently produce some sort of EMF or electric field. And the last equation is the Ampere circuital law. It inherently is actually a modified Ampere circuital law. So these four equations combined, Maxwell combined them and gave the theory of electromagnetism, electromagnetic waves. So these four equations you should know very well, very extremely well. Then the very first idea before we start electromagnetic wave is you should have a very clear idea what is plane waves, right? Mathematically, how do you represent them? And what does each term in this equation represents, right? So plane waves is written as, so first of all, you have two options now. You can write electromagnetic wave either by electric field or by magnetic field. We usually try to write it in the form of electric field. There is no very good reason for that, but this is how things goes most of the times. So if whenever anyone say what is electromagnetic wave, what is plane wave, so you say E equals to E naught, E raised exponential raised per iota k dot r minus omega t. So this is an equation of plane wave. That is the first thing that you should know, that this is how we write plane wave. Here E naught is an amplitude, so you know that your wave is going in one direction. Let's say it is going towards k cap or k vector direction. But your electric field is oscillating in the direction perpendicular to this k. So this is your wave and this is oscillating. This is oscillating. Your electric field has the direction in this. So let's say this is J, then this will be Y. Okay, this will be Y. So your electric field is along Y. It is increasing, then again decreasing, increasing, then again decreasing. So electric field and K vector are perpendicular to each other. So E vector means the direction of electric field, that you should always remember. K vector means the direction of the your EM wave, that you should remember. K vector is given, its magnitude is given by 2 pi by lambda. 2 pi by lambda, it's called wave vector. And K cap is the direction of your propagation of wave. Omega is your frequency, angular frequency, 2 pi nu. R is your just a simple vector in the space, a position vector, xi cap plus yj cap plus z k cap. So this is how you typically write the electromagnetic wave. Now let's play with this equation. That's very important. This is one of the previous year question I like to explain to you. I have picked this question because this question include everything that you need to know. So here one EM wave is given to you. One electric field is being given to you. So number one thing, by looking at the equation, why do you say that this is not an electrostatic field, but it's an EM wave? Why do you think that's the case?
Excuse me, Bhaiya, your screen is not visible.
My screen is not visible, guys. I think it is visible, Sahin.
Yes, where it's visible.
I can reshare my screen, but it's visible. So give me an answer to the question that why do you think that this is actually a EM wave and not a electrostatic field?
We need to check the curl of E. That
You
is
need to check. You can't say by just by looking at it. So you need to check anything, or you see by looking at it that okay, this is not an.
sir, the form is given in the form of EM wave. But
Okay,
if
that
we
is
take the
one.
curl,
Yeah, you are
even
saying
if
it is written in the plane wave. Why it is plane wave, first of all? So very simple ideology. It's an equation. Why do you think it's an EM wave and not an electrostatic field?
sir, if we take the curl of E, okay, so in that it will come non-zero because it is dependent on X and Z.
Okay, so let's say I give you four examples, four options, and I say which one of these is an electrostatic field. So only one of them comes out to be del cross E is 0. So what do you say? All other three are EM waves? Or is it possible? Na?
No.
These are not, all three are not
Yes,
possible.
yes.
So what is that one thing that makes it an EM wave?
It has a exponential term.
Okay, let's say it can be an exponential in electrostatic field also.
Because
Nothing, because the
fields are uniform over every plane.
no, fields are not at all uniform.
It is
Amplitude.
a wave vector term.
Wave
Electric
vector
and
means,
magnetic fields are oscillatory.
yeah, but there is no information about magnetic field here. So the very simple idea to think about is it has a time dependence. Right? Can you see the time t here in the equation?
Yes, sir.
So that inherently disproves that it cannot be an electrostatic field. Second of all, it is exponentially, means sinusoidally or cosine variation of time. So it means it is oscillating. So these two things in itself are saying that this is an EM wave. Very simple idea is that it has a time dependence, and that time dependence is also sinusoidal, because as exponential can be written in terms of sine. You all know that. So that's why we call it as an EM wave. That's why we represent it in this form. So number one thing that should be clear to you. Now, if we compare this equation with the form I just mentioned, the E naught will come out to be, E naught vector will come out to be E naught, which is a magnitude of an amplitude, bracket x cap plus az cap, which inherently represents the direction of the electric field. And what is a K vector? So what we need to do is, this is written as k dot r, right? If we see with our compare with our equation, it is k dot r and this is omega t, right? Omega t. So our k dot r is actually k naught, because this k naught is also here. K naught
Sir,
times,
is not
yeah.
visible.
My screen is not visible. How many of you can't see my screen?
Where your screen is visible, but like it is not updating.
Oh, okay. I'm not much writing here because it's already written. That's maybe why. Okay, I draw a star on the screen. How many of you can see the star? Can you all see this random shape?
Yes.
Yes, I
Yes,
can
yes.
see.
Yes, master.
Yes.
Okay, so let's move on then. So what is your k dot r? Very simple question, very simple thing. K dot r, if I compare with that, is k naught, this k naught which is here, times x plus root 3z. That's it. But what k dot r actually is, k is kx x cap, ky y cap plus kz z cap, and your r is x cap plus y cap. So if I dot product these, you will get kxx, kyy, kzz. And if I compare both sides, kx you will get as k naught, ky you will get as 0, and kz you will get as root 3 k naught. Isn't it? Everything clear till here?
Yes, sir.
How do you find k vector if, yeah, tell me.
Bhaiya, can you show me the first page, like the first form?
Okay, this is a first page. Yeah, you can see that. Right.
Okay, thank you.
So we have just compared it, and k vector we have found it. So is it clear to everyone how we find k vector from an electromagnetic equation? electric field equation. So your K vector comes out to be K naught x cap plus root 3 j cap. Is it fine with everyone? K vector. How do we find K vector?
Yes.
Yes, Bhaiya.
So how, but if we know K vector, what do we got actually? We got actually that in which direction our EM wave is going. Second thing, what is a wavelength? If I give you K vector, can you find the wavelength very quickly? How do you find the wavelength? So the K vector's magnitude is given by 2 pi by lambda. That's it. You can easily find the K vector's magnitude, and from there you can easily find the lambda. So these two informations you have got. Now second information. Now I want you to ask that is this A which is here in E naught, is it random? Can it take any value, or will it be constrained by the other things? That's a number one question we should ask. Is it, can electric field go in any direction, or it has some dependence upon in which direction your wave is going? Or it doesn't matter in which direction wave is going, my electric field can be in any direction. What do you think?
Sir, it has to satisfy the transverse condition.
Right. So it has to satisfy the transverse condition. And what is that condition? That your K vector and the direction of electric field must always be perpendicular. That's why their dot product will be 0. So K dot E naught will be 0. So if you do that simple kind of mathematics, you find that actually your A can only have one value. So this A can only have one value. It means it does not, your what in which direction your electric field is actually is, it depends upon in which direction your wave is going. They both are not independent. They always need to be perpendicular to each other. And another thing, mathematically, you should always remember this equation. K vector dot E naught vector equals to 0. It will save a lot of your questions in the exam, because usually students forget this condition and do not use this formula. This formula is very important, especially in GATE. K dot E 0, or you can even write this K dot E is 0. Okay, because the direction of electric field is actually a direction of its amplitude. That's it. Very simple. Now number 2, why I picked find epsilon or dielectric constant. Epsilon and dielectric constant are very much connected, right? Why? Can anyone give me the relation between E epsilon and epsilon naught? What should I write here?
Epsilon R.
And what is epsilon R?
Dielectric constant.
Dielectric constant, right? So if I give you electric field, sometimes in the questions they ask you to find the dielectric constant or maybe epsilon also. So how do we actually find that? In order to find that, you need to have information about the velocity of your EM wave or the speed of your EM wave. So the speed of your EM wave, all of you know, is actually 1 by under root epsilon nu. How many of you know this? Do you know this formula? Very simple.
Yes, sir.
Everyone knows this. Very simple formula. Okay, so if all of you know this and I am an interviewer, give me the equation from where I can derive this.
The field equations, electric and magnetic field equations.
Which
So
field?
by taking the curl of the taking the curl and then solving it, we will get wave equation, and then if we compare it, we will
Yes.
get
So,
velocity.
yeah, so the answer is wave equation, right? Wave equation. So del square E, okay, C square curly square E by curly T square, right? From this equation, we can actually find this V square. By comparing, we will actually can find the V value. And that value actually comes out to be 1 by epsilon naught, epsilon nu. So if this is V, right? And if I assume that it's a non-magnetic medium, means the medium do not have any magnetic properties, then I can say nu is equals to nu naught. And it is in the most of the cases, it is, you will find that it's a non-magnetic medium. Most of the cases. But we have a dielectric medium. So if it has a dielectric medium, your epsilon is not epsilon nu, it is epsilon equal to epsilon r into epsilon nu, right? So your velocity actually becomes something like this. or in terms of speed of light, if you think, or the speed of EM wave in vacuum, your V becomes C by under root epsilon r. So how many of you understand this? This formula. This formula is also very important. Tell me, do you all understand this?
Yes, sir.
Okay. And one more statement which I want to make here is refractive index is N, right? And it is actually equals to, can anyone tell me what is the definition of refractive index? N equals to?
So under root
C of
epsilon r into mu r.
No, give me the class 11 12 definition. It's C by V,
The speed
right?
of light vacuum divided by speed of light in medium.
Yeah. So C by V, right? So what is C by V here? Under root epsilon r. Right? So these formulas you should know. Very important formulas. You should not get confused in the exam through these formulas. So if someone gives you an electric field and asks you to find the refractive index of the medium, you can easily do that. Very easily do that. Okay. Now let's move on. We can do that if we can find the epsilon r. Till now we haven't find epsilon r. How do we find epsilon r? This is a general formulation which I have done. I haven't introduced my electric field yet. So what are the parameters of the electric field which connects with the speed? That is omega and k. So another formula for speed of light is V equals to omega by k. And why you should believe me that V equals to omega by k? Because you know V is equals to nu lambda. This everyone knows. V equals to nu lambda. Frequency times lambda. Am I right? This you all know.
Yes, sir.
So if I multiply 2 pi and divide by 2 pi nu by lambda by 2 pi, isn't it becomes omega by k? Very easy. So V becomes omega by k. Why I write V in terms of omega by k? Because omega and k I can find from my electric field, right? If anyone gives you this kind of equation, you know what omega is, you know what k is, right? So that's why I want to write my speed in terms of omega by k. So from that equation, you have already found the k. This we have already found. If we take its magnitude, you found 2k naught, right? Very easy. I give you 30 seconds to understand the magnitude is 2k naught. Just try to think. Okay, so is it clear? Magnitude should be 2k naught.
Yes, sir.
Everyone clear? Everyone with me?
Yes, sir.
Yes, ma'am.
Okay,
Yes.
so k is 2k naught. But now let's go and see what is omega. So omega is C into k naught, right? C into k naught. Is it or not?
Yes, sir.
Because if I compare this with omega t, it becomes C into k naught. So let's come and write C into k naught. So I came and write C into k naught. So my speed actually comes out to be C by 2. So my EM waves is actually traveling with half the speed of light. Right. So if I compare this equation and this equation, I found epsilon r to be 4. So how many of you understand this sort of mathematics? Very easy mathematics. Epsilon r is 4, right? Got it? Got an idea?
Yes, sir.
So what are the things which we learned in this question? Number one, that whenever EM wave is given, this first term is called E naught vector, right? This thing, whatever is with the time, that is omega, and whatever is in this spatial part, whatever is this spatial part means space part, is actually k dot r. So once we know the k, just by looking at the equation, we can actually find k and omega. So once we know k and omega, it is very easy to use k dot e equation. We have to keep in mind that our k vector and e vector are perpendicular. So k dot e is 0. That's a number 2 thing which we learned. So they are not both independent. And then we did a little bit good thing that is actually missing in the books, that how do we find dielectric constant or the refractive index from the EM wave that is being given, or how to find the speed of light, speed of your EM wave. So that formulas, few formulas which we did is V equals to 1 by epsilon nu, number one formula. Then second formula which we do is refractive index is under root of epsilon r. Very nice. And third formula which we did is V equals to omega by k. All three are very simple formula and can easily be derived in 30 seconds. So now should I move to next question, or do you have any questions still here?
No, sir.
Okay, so let's move to next question. So number one question is done, that how to read EM wave, how to read a plane wave. Second is very interesting question that actually comes in exam a lot, that they will give you electric field or a magnetic field and they will ask you to find the second thing. Let's say they have given you electric field, they will ask you to find the magnetic field. So first of all, before we jump to do that, first thing is this electric field has been given to you. So now do you understand why it is EM wave and not a standard electrostatic field? Because still there is a time dependence here, right? So I want all of you to think that is this K right or wrong? What K I have written here, is it right or wrong?
Yes, sir. Right.
But yes, it's right. Everyone can imagine that. Based on the simple previous question, it's simple that K
Yes,
dot
yes.
R is this. So omega is 1000 pi. This is also right, I think. And E naught is actually E naught into K. So by looking at this and by looking at that, can you tell me in which direction EM wave is going?
The K cap direction.
No. Let me give you an example. North, south, northeast, northwest. Give me answer in this form. So let's imagine
Northeast.
Northeast.
northeast, right? So this is north, this is east, this is I cap, this is J cap. So your wave is going along X and Y. X and Y. Second thing I want you to answer is, let's say these are two angles. This is theta 1 and this is theta 2. So theta 1 is bigger than theta 2 or theta 2 is bigger than theta 1?
So theta 1 is bigger.
Why? Why you think theta 1 is bigger? Sorry, let me, yeah, this is theta 2. Okay, so this is theta 1, that is theta 2. Which one is bigger? Not from my diagram, but from the equation, which one is bigger?
0.4 is greater than 0.3. So the
So vector is more towards Y.
inclined towards
Y
J
cap, right?
J cap, yes.
So by going less in X, it is going more in Y. So this angle is more, right? What do you think?
Yes.
Yes, yes.
So angle is more than 45 degree, but less than 90 degree. So this is how you should actually, before doing the calculation, should know about your EM wave. Okay, so number one thing. Now tell me in which direction your electric field is oscillating.
K cap.
Z direction, right?
Z,
So
Z,
out of the
yes.
plane, out of the plane. So now, do you think there is a great amount of liberty here? Now you can imagine EM wave could have been in anywhere in this plane, and still if your electric field is oscillating in Z direction, in all those conditions, it will be perpendicular to your plane, right? Z cap is always perpendicular to XY plane. So your EM wave could have been in anywhere in this plane, right? It could be here, right? It could be here. It could be here. All of these will satisfy the condition that E dot K will be 0. Right or wrong?
Yes, sir.
Everyone got this point? Everyone got this point? Your EM wave can go in any direction. Go here, go here, go here, go here. As long as your electrostatic field is oscillating in Z direction, it will be perpendicular to
Yes.
your electric field. So in last question, I told you that EM wave and the direction of electric field are interdependent, but it does not mean that there is a unique two values. There could be a set of values possible for your electric field to oscillate or your EM wave to go in some direction. There is a set of values. They are both dependent, interdependent, but it does not mean that there is a unique two values which E naught and the direction of K should have. Right? That you should always remember. So I am just picking the questions in very depth so that you actually understand the concept also of EM wave, how to imagine. So now this all information has been given to me. Now they ask me, okay, so you have electric field, give me the magnetic field. How do we find the magnetic field? So now we have to come to Maxwell's equation. So whenever electric field is given to you and you have to find the magnetic field, always use this equation del cross E equals to minus curly B by curly D. And if inverse is given, let's say you have given a magnetic field and you have to find electric field, use this equation. Right? This is a Ampere second law when free charge density is current density is 0. Okay. So when magnetic field given, can anyone tell me why we can't use this equation in this case and vice versa? There should be a logic behind everything. Why we can't use this equation when electric field is given and we need to find magnetic field? Any idea, anyone?
Sir, because for electric field only tangential components are continuous.
You don't have to go in that much detail. See, first thing to ask
Sir,
is
sir, we
both
are
equations
given.
valid? Yeah,
Sir,
both
but
equations valid, right?
yes.
So
Sir,
why?
here we are given E. Okay. So
Yeah.
we have to. So if we want to find B, then we will have to imagine Bx, By, Bz. So three unknowns
Yes.
will come.
Yeah. So
If we,
in order to reduce the number of unknowns, he has given the right answer. Why? You know E, you can easily find del cross E. Right? But if you start using this equation, you don't know B here. How will you find del cross B? You have to be in the form of general. You have to imagine that B is actually Bx, By, Bz, and then you will make the three equations, compare them and find the answer. In this, you can easily find del cross E and it's just curly B by curly T. You just have to integrate with time both sides and your B will come out. You don't have to do any mathematics with B and you will see as I will do this question. So always remember, whatever you have, do the curl of that. If you have E, do the curl of E. If you have B, do the curl of B. Okay, always remember that. So we have E, let's do the curl of E. So E is along the J cap. So we have put it in along the J cap. And if you do this curl and do the little bit of mathematics, you will come to this. I do not need to explain you the mathematics. It's a very simple mathematics that anyone can do. Now, you have found curly B by curly T, but you need to find B. What do? You just integrate with time both sides. So you have integrated with time both sides and you have found the B. Very simple. It's a mathematics that no one needs to explain it to you. You can easily do it, right? Everyone can do this sort of mathematics. Can you find the B? Very simple.
Yes, sir.
Everyone
Yes, sir.
understood what's the algorithm that I need to explain to you. Okay, so if everyone is clear with the algorithm, so and the main hit of this question was whatever you have, do the curl of that. Use that equation in which the curl of that thing is involved, which you already know. Okay, but this is a full procedure of doing. There is some short things also which you can do or which you should always remember while solving such equations. So these 3 points I want you to remember. So let's say B naught is a amplitude of magnetic field and E naught is an amplitude of the electric field. So it follows this simple equation that B naught is equals to E naught by V. So what does this equation tells you? Which is bigger, B naught or E naught?
B naught.
B naught is bigger.
E naught.
E
E
naught.
naught.
E
Electric
naught
field.
is,
E naught is bigger.
E naught is always bigger. And how much bigger? Almost bigger by the amount of speed of light. That is roughly 10 raised per 8 times bigger. Right? So you always should always remember that we usually, whenever we draw the magnetic field, and we have seen these kind of drawings, right? So these kind of drawings are very much wrong, right? Because it actually is telling that electric field and magnetic field has a same amplitude, which is very wrong. If this is an amplitude of electric field, D should be something like this, isn't it? It is 10 raised per 8 times smaller.
Yes.
So always remember this. And whenever you have to check, you can easily check that B naught is E naught by V. V we have already seen, it's 1 by under root epsilon naught epsilon nu or omega by k. Anything you can write. Second thing that you should remember is the direction of EM wave is actually the E cross B direction. If E cap is the direction of electric field, just direction I'm saying, and B cap is the direction of magnetic field, then if you do E cross B, then you get the direction of EM wave. It's not reverse. Always remember it's E cross B, not B cross E. So one point you should remember this, and second point you should remember this. And the third point, which we have already covered, that E dot K and B dot K is zero. Why? Because electric field and magnetic field and wave direction, all three are mutually perpendicular to each other. So these 3 points, if you remember, you can eliminate the options as well and do the question even more easier in easy way. Now we have seen what is E dot K, B dot K, but we haven't seen what is E cross K and B cross K. What do you think? Will it be zero or non-zero? In general.
Yeah,
No, non-zero.
Non-zero, right? So if you do E cross K, can I say it will be in the direction of B? How many of you can imagine that?
Minus B.
No,
Yes,
B,
mine.
B or minus B, anything. Don't
Yes,
worry,
yes.
but it will be in the direction of B, right? And if I do
Yes.
B cross K, it will be in the direction of E or minus E, whatever.
Yes.
Yes, sir.
So exact we can find from here. This example I have given, in which you can actually find that what is E cross K and K cross E. Oh, sorry, K cross E and K cross H. Why I used H here? Because I also want to give you two additional parameters, H and D. Now, one very much confusion here, which students usually have is, and which I want you to give as an homework actually, is units. So you all must have seen the all must have seen these two parameters, H and D. But I want you to read more about this and find the units of, or know the units of H, D, B and E. Because most of you will give me the wrong answer. If I ask you what is the units of, or if I give you the Tesla is a unit of magnetic field. But is it a unit of H or is it a unit of B?
B.
Are you sure about that?
Yes, sir.
So if Tesla is a unit of B, then what is the unit of H? Okay. Number 2 question, which you should know. I will not
Sir,
give
I
the
think
answer. Yeah.
Sir, I think Weber is the unit of B and Tesla is the unit of H.
Yeah, you are I want you to say you are right, but I will not give the answer. So second thing which you should think about is that when I say you apply the magnetic field, you apply H or you apply B?
So B, sir.
You apply B. How many of you
Yes.
say you apply B? Tell me.
Because H is a mathematical quantity. It has no physical existence.
Yeah, that's a confusion. When first time reality hit me, it was very surprising for me as well. But the reality is when you say that you apply a magnetic field, you actually apply H. B is a behavior of magnetic field inside the any material, and H is something which you apply, but it is reverse in electric field. E is something which you apply, and D is the behavior of electric field inside the material. Understood? Now you have to understand the correct meaning of all four and what are the units of all four, because I can guarantee you in this time gate exam you will need this. 100% you will need this. So one thing which I have already told you, you should remember that whenever you say we apply magnetic field, you apply H. And whenever you say I apply electric field, you apply E. And what is the behavior of electric field inside material? That is given by D. And what is the behavior of magnetic field inside material? That is given by B. Okay, understood? So these four things you should know and their units. Okay, so there is a simple mathematical relation between H and B, that is H equals to B by nu, that you all know, and D equals to epsilon E, that you also know. So we now need to find what is K cross H and K cross E, because that we don't know. K dot E and K dot H is 0, that we know. Okay, so how do you find that? One way is we go very general, but we don't need to go that much general. We can just assume any electric field. So let's assume electric field is towards I cap and your EM wave. Can you tell me by looking at this equation in which direction EM wave is moving?
Z.
Yes. So electric field is along I cap and your EM wave is going towards Z. Similarly, your B vector, it has now only one option. It has to go towards Y axis and your EM wave still is going towards the Z cap. So these three equations are there. So now you can do easily K cross E because that's what you need to find. So when you do K cross E, you get into something like this and then you play with these equations. Okay, then you have to simply play with this and you will find that K cross E is equals to nu omega H cap, and that's what we were actually expecting, right? K cross E should be in the direction of magnetic field, and that's what we have got here. Similarly, K cross H will be in the direction of some electric field. So this you can easily prove. I will recommend you to do this question because in the exam usually you do not remember the exact formula and sometimes you actually need the exact formula. And this kind of question has been exactly asked in the gate, right? So this is what I wanted to make sure. Before I move to next point, any question till here?
But we know that
Yeah,
electric field is having more amplitude than like magnetic field, much more times. But while the carry energy, it is equally distributed with magnetic and electric field. Why is that happening?
yeah, because magnetic field is much stronger than electric field. I give you an example. Having a 12 volt per meter of electric field is nothing, right? It's nothing. But having a 12 Tesla of magnetic field is a huge number. You understand? Do you agree with
Okay.
me?
Yeah, yeah.
So how magnetic field carry the energy and how electric field carry the energy, there is a different mechanism in that. So both do not need to be comparable in the numbers in order to carry out the same energy. Because 12 Tesla magnetic field is a huge number. It's a huge number. But 12 volt per meter is okay. Anyone can supply that. Right? So that's it basically. Okay. Now, any other questions before we move forward?
Yes, sir.
Bhaiya, can you repeat the
But
applied electric field and magnetic field part, like the B, H, and E and D?
okay. So whenever someone asks you what you apply magnetic field, it means you have applied H. H is something which you can apply. And but whatever field you have applied, and there is a paramagnetic material here or diamagnetic material here, inside this there will be different magnetic field. What is a magnetic field inside a material? That is determined by the number B. But what you have applied is defined by the number H. But in electric field case, what happen is, let's say you have applied ferroelectric material. You apply E, or dielectric material. You apply E, but what is the electric field inside is determined by the number D. Understood?
Yes,
Sir,
Bhaiya.
where can we
Sir,
read this concept more
sir,
clearer?
If
sir,
you really want you to be more clearer, read Puri and Babbar solid state physics and read the chapter what is that, magnetism in solids, chapter number 8.
sir,
Yes,
sir,
tell me. Yeah,
in Griffith's, there is some one paragraph on this.
right.
That sir, theoretically D and H are same, but from experimental point of view, if we want to, we can only apply H because we only measure currents
Yes.
to build an electromagnet. So H should be, sir, the field inside the material.
So I am
According to that.
again telling you whatever I have said is right. You have to read it again and interpret it rightly.
Okay.
And you also have to look upon that what H and what B notation Griffiths have given. Is okay. If this formula is that, then whatever I'm saying is right. And this is usually right.
Okay.
And I am pretty sure Griffiths has also given the same thing. Okay.
Okay, sir.
Okay, so we should move forward then. I think it's clear to everyone till here. Okay, so let's move on. EM wave is incomplete without discussing about the energy, intensity, power, and so on. Because we have a EM wave, right? EM wave hits our eye see something. We get energy in our eye. Or our skin burns because of infrared, because of UV, right? Our food cooks because of the microwaves or because of the infrared rays, right? Our cell phone rings because of the radio waves. So there is energy in these EM waves. What is that energy? If there is an energy, then we automatically know there is an intensity, right? Energy per unit area per unit time is intensity. If there is an intensity, we also know there should be some sort of power with these waves. How do we find these numbers if electric field is given to us? So there are some few basic formulas. So number one thing is pointing vector. This is a very crucial thing, and I am just giving you what pointing vector is, but I strongly recommend you all to see the Griffiths book and see how pointing vector comes. I will just give you the definition and what does it represent, but you should know how pointing vectors comes into this picture. Why it is E cross B divided by nu, or it is E cross H. So very first thing is, if your pointing vector, which is some parameter, is E cross H, it means it is pointing towards the direction of EM wave. Am I right or wrong? Because E cross H is a direction of EM wave. Right,
Yes,
this
sir.
we have already seen. So your pointing vector is also towards the EM wave. So S is in the direction of the EM wave, but what does S represents? It represents energy flowing in the EM wave or energy carried by the EM waves per unit area per unit time. So what is energy per unit area per unit time?
Intensity.
Intensity. So if you do the time average of pointing vector, it gives you intensity. Why not just S is an intensity and only its time average is intensity? Can anyone guess?
Sir, because of the fluctuations, so we have to neglect the fluctuations because they are very fast enough. So we have to take the average.
No, they're fast or slow. It's not always fast, right? It's fast in light. It's very slow
That is
in
So
radio.
because
that is
EMA we just add a serial.
instantaneous. S gives instantaneous value,
Right. Yeah, and
which might be.
intensity, yeah, it is per second. You understand? Per second. And if you see per second, it means you're not talking about per cycle of EM wave. You're talking about per second. Per second means you have already averaged it. You want to average it in order to see the time effect per second. You want to see that what is. So in 1 second, let's say 1,000 times EM wave is oscillated, then you will look upon the average behavior. So the average time average of Poynting vector actually gives you intensity, because intensity is never defined as instantaneous intensity. You never define intensity as at this time intensity is this, at this time intensity is this. Intensity is always an average phenomenon. Always remember this. In many interviews, they will ask you, okay, that intensity is actually an average phenomenon. Yes, Hardy, tell me.
Sir, can we also tell that we cannot measure instantaneous value experimentally?
Even if you don't want to, you can't measure it. Your
Experimentally,
EM wave will give that to your system, right?
that's right. But experimentally, we can only measure time average. That's why probably in that book of optics I have read, Eugene Hertz, there is something mentioned about this.
So intensity is inherently always time averaged, which I believe
Yes.
that. Okay, at every because EM wave, usually light. If you have read this in optics, it means you are discussing about light. Right, I am
Yeah.
looking at the broader aspect of EM waves.
Okay.
In light, what happens is in 1 second, it's 10 is per 15 times it is oscillating. Right, it makes 10 is per 15 cycles in 1 second. So it's already time averaged. If you look for intensity for 1 second, it means you have averaged it for 10 is per 15 cycles. Right, so you can't find one point. You have to see the average. But in other sort of waves in which frequency is less, you can actually find the instantaneous things as well. But intensity is always an average quantity. Okay, so S is what? S is energy flowing per unit area per unit time. But if you do its time average, you will find that it's an intensity. Okay, and its formula is given by E cross H or E cross B divided by nu. Right. So let's see, there are two. Now what is energy and what is intensity in terms of the electric field? We always have to ask ourselves the question that this is a general formula, right? Very interestingly, I find that. But always you will be given electric field or magnetic field. From there you have to find energy and intensity. So let's say you are given electric field, very general, magnetic field, very general. Okay. So you are asked to find the energy stored in the electric field, and it is given by half epsilon E square. And I want you to explain why it's half epsilon E square. From where this is coming? Give me a formula from where this is coming. Very quickly. You all have studied that in electrostatics.
We want to assemble when we assemble charges. We
So
met
yeah. So the formula you must have studied is you have seen this formula.
Yes.
Right. So half epsilon naught. Okay. And E square. If I integrate, this will be volume. Right. U by V. U by V is actually the energy density, which I have written here. Energy density means energy per unit volume. That is half epsilon naught E square. That's what is written here. So all of you understand why energy stored in electric field is half epsilon E square. This actually comes from electrostatics. Similarly, if you see from magnetic field, the energy stored in magnetic field is 1 by 2 nu B square. Right? Now, if it is a free space or in vacuum, you know epsilon is epsilon naught, nu is nu naught, and B I have already told is E by C, and C square is actually nu naught epsilon or 1 by nu naught epsilon. Doing all that mathematics, you actually find that in vacuum only, not in any other material, only in vacuum, the energy stored in magnetic field and in electric field is equal, which that person already asked the question. But that is only true in vacuum or in free space. It's not true always. Okay, so the energy stored in magnetic field and electric field is equal, and that is equals to half epsilon naught E naught square, or half epsilon naught E square, or 1 by 2 nu naught B square. Anything. You can write it in any form. It is equal. Okay, second thing. What is the total energy then? You just have to take half epsilon naught E square multiply by 2 epsilon naught E square. Always remember this. Why I want you to always remember this? Because what happen is in the questions sometimes they ask what is the energy stored in the EM wave, and most of the people use this formula, and you will be wrong, because the energy stored in EM wave is double. It's energy stored in both EM electric field and both in magnetic field. So you have to double this number. Do not use half epsilon naught E square. If they ask what is the energy stored in electric field, only then you say half epsilon naught E square. So is it clear till here?
Yes, sir.
Yes,
Right. Epsilon, you know, is already given to you. You have to only have to square it. Its amplitude. You only have to square its amplitude. E naught square. Right. So that's it. Find its magnitude and square it. So you will find the energy. Is it energy or energy per unit volume? That is also a very important point.
So per unit volume.
Can we define absolute energy? Let's say I do not want to find energy density. I only want to find energy. Can we do that in case of EM waves?
Sir, because it is spread over the entire space, we have to integrate over infinity. So.
But we can do it, right? It's not a big deal. If I ask you what is the energy stored by EM wave in this box, can you define that?
Yes, sir.
So whoever is saying yes, you have to think about it. There is a light bulb source inside or light bulb source outside?
Outside.
If it is outside, the EM waves entered and then left.
Yes, sir. It will be 0.
But if the light source bulb is inside, the light is continuously being emitted. So some sort of EM wave is always inside this box. Right?
Yes.
So
Sir.
what do you think? Can we define electric energy, energy in EM wave absolutely, or we always have to find the energy density?
So density.
How many of say we always have to find energy density? I just told you, na, if source is inside, you can multiply with V, right? Just multiply with the volume of this cube, then you will find the energy which is inside this. Isn't it? You will get the total energy inside the box. But now there is one more problem here. There is one more problem here, which is very crucial to know. You have EM wave like this, okay, going in all direction, and you multiplied it with V. You multiplied it with V. But how do you actually, in the mathematics, say that V is around this point? V can be around this point, or V can be around this point. And in all these cases, energy will come out to be different or same?
Different.
Different.
So mathematically, you can't make sure that it is around the source. That's, isn't it? You have just
Yes.
multiplied with it with V. You haven't said anything about the origin. So that's why we always define energy density only. We never, it's very difficult to define energy absolutely. Okay. Because of these complications. In order to actually in order to actually give the value of, coordinate information, then you have to do the integrations. E square D norm. And you, when I explained you here, you saw that I actually took E square out and only kept D tau inside. Right? I I took E square out, right?
Yes, sir.
So that's why it's very complicated procedure to define energy as an absolute value. Okay, so let's move on. We all know, we have understood basic. So these questions will be asked to you in TIFR interview or IISc interviews. So that's why I have discussed this. Next thing is there is a relation between pointing vector and energy density. Pointing vector is, can you all mute yourself? Okay. So pointing vector is energy per unit area per second, and your energy density is energy per unit volume. So if you multiply it with the speed of light or whatever is your speed of EM wave, you see meter per second. So both units become equal. Right now it's equal. Before it was not equal. Now it's equal. You understand this?
Yes, sir.
So that's how you can remember this formula between S and the energy density. Right? And this I have already explained you. What is time average Poynting vector? Time average Poynting vector is nothing but intensity. And there is again a formula, because S is already, you know, is U C K cap. So time average S will be time average U into speed of light. Nothing else, no new thing is here. And the last formula which I want to give you today, tomorrow again we will have EM wave class, but today last formula which I want to give you, if there is an intensity and this EM wave hits the surface, let's say there is a surface and EM wave came and hit it at some angle theta. What is the pressure exerted by this EM wave on this surface? So if this light is totally absorbed, then the pressure given is I intensity divided by C into cos theta. But if it is reflected back, then it is 2I by C cos square theta. This is a formula that you do not need to do the derivation, but this formula will definitely come in exam. So remember this. Before I conclude today's class, I want you to give one small homework, which you can take a screenshot. That's very important. I have given you magnetic field and I want you to find these 5 things. If you do that, you have a good grasp of EM wave now. Number 1, you have to find electric field. Then once you know electric field, magnetic field, you can find Poynting vector. Then if you know Poynting vector, then you can find time averaged Poynting vector. And if you know time averaged Poynting vector, you can easily find time average electric energy and magnetic energy. And in the end, I want you to find what is the pressure exerted by this VM wave if it is absorbed by the Z equals to 0 surface. Okay, so Z equals to 0 surface is needed because you need to know what is an angle between EM wave and the surface. So if you can find these all 5 things, then it's a good summary of today's class. Right now I can take all your questions. For today, it's the end of the session.